Seems we are good to go now. If I'm audible, please reply in the chat box. Awesome. So yeah, let's head on to for today's session. So hello and good afternoon, everyone. Welcome to the Machine Learning Study Jam session 2. And before heading on to today's session, I would like to thank all of you for your positive and active participation in session 1, which was held yesterday. And today we bring into you this session in coordination with DSCs from Charuset, ADIT, GSET, and NLJIT. And today we have the leads from this chapter present with us. So let's have a word from them as well. Starting with me, I am Hariom Yagnik, leading student community under DSC at New Age Institute of Engineering and Technology. I have been a Microsoft Launch Student Ambassador since Jan 2021, and I am very much thankful to all my fellow leagues present here to pull out this session. We genuinely hope that we pull out some of the important session from today's event. Awesome. So now let's have a word from Vaishnavi Somani, GDSC lead, Charuset. Vaishnavi.
All right. Glad to be here. Very good afternoon from me and little Darth Vader over here. All right. I am Vaishnavi Sonavane. I am the lead of GDSC Charoset. And yes, even my specialization and domain is machine learning and computer vision. Apart from that, I am a writer and part-time stand-up geek, as I say. There are my social media handles on the screen. So feel free to reach out to me anytime. Looking forward to a very great session, guys.
That was awesome. Now let's head on to Preet Thakkar, GDSC lead from ADIT. Preet.
Hello everyone, I'm Brit Thakkar. I'm GDC lead of ADIT and I'm a TensorFlow certified developer and I work as a web developer and a server administrator at Hunt Digital Media Private Limited. Also, these are my social handles, Brit Thakkar, LinkedIn. So you can reach me out there if you have any doubts or queries. Let's pass on to that. Thank you.
Darp.
Hello everyone, myself Garg Amalia. I am GDC lead of GH Patel College of Engineering. I am a main stack web developer and also I am a part of so many society on my campus. If you guys have any help regarding the leading club or societies, you can free feel to reach out to me. Here mentioned my social media accounts. You can ask reach out to me anytime. Thank you.
That was awesome. As you can see, we have some most talented folks present with here and who are pulling out this session for all of you. And without any further ado, let's head on directly to the session and for which we have Ayush Ghiria with us, and he'll be the speaker for today's session, and he will be educating you on what is feature engineering, overfitting and underfitting, followed by model building and evolution. So I would like to pass on this session directly to Ayush. Ayush, you may continue from here.
Yes, thank you, Ariam. Yes, hello everyone. Myself Ayush Gadia, ML team member at GDSC Charuset. I'm also a Kaggle notebook expert. So let's get started. So yes, is my screen is visible? Hello Vaishnavi, is my screen is visible? Hello, can anyone confirm that?
So screen is visible.
Okay, okay. Yes, we have covered the two phases in the patient life cycle, that is analytics, or you can say the data. So this is very important, very important in life cycle, because we need to understand the data, which type of our data is trying to say, or building our model, before building our model. So for this part, which is feature engineering, or we can say, or the data exploratory data analytics, the statistical concept and the mathematical is very important. Machine is all about mathematical optimization and statistical interpretation. Like in today's session, we will cover the cover the topics which include feature engineering, which is the most important part of any machine learning. Uh, work on mostly the feature engineering and analytics part. So for fitting what is feature engineering? Is the process of selecting, manipulating, and transforming raw data into features that can be used in supervised learning. In simple words, like feature engineering is a step for data preprocessing we generally use to improve the performance of our model. Right. So feature engineering includes the handling of missing values, handling of categorical or text data, handling of outliers, feature selection, and also the normalization of data, so on. So let's deep dive into it with the hands-on. So to demonstrate that, I have used the wine quality prediction, which on the basis of some attributes like uh, we will get to know whether the wine is good quality or bad quality. So starting with firstly, I had import the libraries which is NumPy, Pandas. NumPy is used for the linear algebra, and Pandas for data preprocessing and input output CSV. So after that, we will read the data set by using pd.read CSV. After that, by using df.info, we will get to know about the basic info about our data set. So here we will see the which type of data is present in our data set, like which type of attributes, or we can say the features which will present in our data set, like fixed acidity, volatile acidity. These are the features in our data set. After that, we will see which type of class are present in particular data set, that is unique category. Like here we can see that bad and good, two type of class are present in our data set. After that, we will end the step like how many total columns and rows are in our data. So data engineering includes the handling of categorical and text data. So here we can see the quality like form of textual representation. So firstly, we will handle that all data by mapping that particular bed into zero. And after that, we will see the how much null value are present, and if there is any null value, we need to handle it. After handling the categorical value, let's dive into some visualization and data analytics. So firstly, I had done like how many total data of bad or how many total data of good are present in our particular data set. After that, I had done like this sns.pairplot is used for the data for the distribution of data with respect to our target variable, which is quality. So here we can see that every row and column, the distribution of every row and column with respect to particular target variable is shown with the use of sns.pairplot. After that, there is one concept in the statistic which is known as correlation. By using correlation, we get to know that how we get to know that the relationship between that particular two columns. We can also use that correlation for the feature selection purpose. So after finding the correlation, we can see that the highest correlation is particular 0.67 between the fixed acidity and pH value. After that, I had shown the how our data is distributed on basis of for particular on individual column. Either the data is distributed normally or left skewed or right skewed. These all are the concept of statistical which we need to understand before learning any machine learning concepts. So statistical fundamentals are very important in order to do the feature engineering or EDA part. After that, we will we already uh, do the encoding of bad good qualities into 0 and 1. So the quality column is not required in our data set. So we will drop which is unnecessary for us. So we will drop that column using df.drop. After we can see that after we can see the information by using df.info. Here we can see that quality cat is in the integer form. So our model will not understand the string, or we can say that object data type. So we need to convert that into float or integer before doing any further steps. After doing so, we will split our data set into xtrain and ytrain. So xtest which we will use for the later evaluation part. After doing that xtrain and white train test split, we will do the standard scalar. So in firstly, I discuss about the we need to do the normalization or standardization in order to use in order to in order to get the particular values from range 0 to 1. Like why we are doing so? As in our data set, there are values. Some values are very small, right? And other value in other feature like total sulfur dioxide, some values are very 34, 67. So we need to map into particular range which is 0 to 1. So the computation will very easy for the model. So let's discuss about the overfitting and underfitting part. So overfitting, this where the situation where any given model is performing too well on the training data, but the performance drops significantly over the test set, which is called overfitting model. Like overfitting, we have low bias and high variance. Bias means the error in the training set, and the variance we have the error in the test set. So in overfitting, what general is the error in the training set is low, but when we are doing the model evaluation part, the error is very high, and we will not get the accurate result. Suppose, for example, we can take example of suppose one student and before the exam the syllabus is very big, and he need to complete the all the syllabus. So what he will do, he will learn everything, he will learn everything before that one day, and but on the exam day he will not perform well. So he did from his side, he learned everything, but at the exam time he will not get accurate result. So this is the example of overfitting. Like our model will learn everything from the data, but we will not perform good on the test set. What is meant by underfitting? The situation where any given model is performing not well on the training data or not well on the test data as well is called underfitting. Like if you take the example of student, if like before exam he did not study anything, and on the exam absolutely obviously like he will not score good marks. So this is the example of underfitting. What is the generalization form? Suppose any student did 80% of the syllabus, and in exam also he did score up to 70%. So this is the generalization form. So our main aim was to build a generalized model which will perform on both like training data and as well as testing data. So which are the techniques to reduce overfitting? So we can do the training, we can increase the training data, we can reduce the model complexity by removing feature which we will shown in the uh, which we will show ahead. Early stopping in the training, which is the concept in the deep learning. Like if the error is not reducing or not optimizing, then we can stop the training and by creating some checkpoint. Regularization. There are two types of regularization, L1 and L2, which is there in Lesho, which the concept of L1 and L2 in machine learning, and also deep learning. As ensembling, which will see ahead about the machine learning, which different ensembling models like random forest or boosting techniques like XGBoost, which will solve the problem of overfitting. We will also see the cross validation technique in order to reduce the overfitting. Generally, non-parametrics model like decision tree, KNN, and other tree-based algorithm, we are very prone to overfitting. So firstly, we will take the example of overfitting. Like let's take the decision tree. We hold our model like decision tree classifier. We fit our model into with the help of training data. Now let's check the score. Here we can see that score is X10 and Y10, which is 100%. We will training accuracy is almost 100%. But when we are testing into our test set, accuracy is decreases. So this is the best example of overfitting. So this is the confusion matrix, like how many actual predicted, how many false positive, false negative, and so on. Visual representation of our output. So here we can also evaluate our model by using classification report. In classification, everything is available. Like suppose accuracy is available, precision, recall, and F1 score. These are the measure to evaluate any classification techniques. After that, let's tune our decision tree classifier, which we built earlier with the help of some hyperparameters. So we can see that we had some hyperparameters like maximum depth, maximum leaf nodes, and we can see that accuracy is increased. As we discussed earlier, there are methods like cross validation, which will help us to reduce the will help us to reduce the overfitting. So here we can see that we had taken the cross validation score. We had used the model 3, which is our decision tree classifier, and we have trained into 10 samples. What is cross validation? First of all, we can see first cross validation means like in our data set is divided into 10. Like here we can see, here I take the 10. So our data set is divided into 10 parts, and in every individual part will be trained and evaluated individually, so that step by step learning will be there. So first of all, in like we will not learn the data in entire data in one iteration. We will do the step by step learning so that learning will be more efficient. After that, we can above we can see that ensembling method will also reduce the overfitting. So let's take one example of like particular ensemble method, which is random forest classifier. So here model 4 we will take as a random forest classifier. We will fit into X train and Y train. Here we can see the accuracy of our training set, like it is 100%. And accuracy of test set is 76%, which is higher than the decision tree. Yes, there may be overfitting, but which is not as similar to the decision tree. Here also we can use the cross validation techniques in order to reduce the overfitting. Here, and so in 10 iteration, the different output, different accuracy will be there, but by taking the mean of all the 10 iteration, we will get the particular accuracy, which is 73%. So after that, one technique is there, which will very helpful in order to do feature engineering, which is feature selection. In machine learning, there is one curse, we can say that curse of dimensionality. If the dimension in a particular data set is increased, then it will affect the performance of our model, right? So as the dimensionality increase in our particular feature in particular data set, then it will affect the performance of model. So in order to, so in particular, if this data set is small, like particular 10 to 12 feature is there, but in real world there is this type of data set will be not there. There are many 200 300 columns will be there, but every column is not important for our particular model. Some are which is with the necessary column will be, we generally take the all the column for training set, which will affect the performance or model. But there are some features which is not important, so we will eliminate that. But how we can do that, how we can select the particular best we can select the most important features from our data set. There may be, like in when we use the ensembling models method like random forest, or we can select by using that we can select the feature, we can do the feature selection. There are many methods like chi-square test or statistical methods like chi-square test. You can say that Lasso regression. We also do the feature selection from that also. Earlier I discussed about the correlation, which will identify the relationship between the two features, right? So we can also do the feature selection by using correlation method, but here I take example of particular random forest. So we will see the first of all, I select from the model, and I have used the random forest classifier and give and fitting on the training set. After that, I like by using get support, we will get that which features are most important in order for our model for or our dependent on the particular target variable, right? So here we can say that volatile acidity, total sulfur dioxide, density, and sulfate and alcohol. Out of 11 features, these 5 features is very much important. So by after eliminating the unnecessary feature, or our accuracy will be increased. This is the one way of feature engineering, or we can this also help us to reduce the overfitting also. After that, let's after selection, we can see that after we'll train our random forest classifier on by doing some hyperparameter tuning. We can also do hyperparameter tuning manually by using trial and error method, or we can also use the grid CV, which will do the trial and error method by computationally, and we will get the most important parameters for our particular random forest classifier. Where the error rate is less, we will get that particular parameters. So this will also use to increase the performance of our model, like hyperparameter tuning. After hyperparameter tuning, we can see that training score is 93 and the test score is 75%. Now we will show the confusion matrix, which is so. Yeah, that's all from my side. So any questions? Yeah, sure. So which visualization are you talking about? Like this confusion matrix or anything else?
Hello. Hello. I
Hello. Yes, yes.
yeah, just open that Kaggle notebook and they'll point out where they missed out.
Yes. Which visualization he's talking about?
Maybe just explain first three or four. I think those were enough. Those were skipped actually.
This one?
No, this was covered actually. Yes, about this. Yes, this was skipped.
So that distribution one.
Yes.
So by using SNS.pairplot, we generally get to the distribution with respect to particular target variable. Like our target variable is like two class, like having bad or good quality. So this is the representation of two classes and with distribution of with respect to every columns. Suppose we have this is very small, like fixed acidity. So with respect to fixed acidity, we generally have the particular normal distribution, but with respect fixed acidity, with respect to we can see that volatile acidity, but if you use quality uh, distribution of particular target variable with all the columns. So here we have two class, so that's why the two colors will be there, like orange and blue. So
Okay, that was amazing. Would you mind sharing this Kaggle notebook link in the chat section?
oh, yes, yes. So any more doubts?
Okay, that was so amazing. So, hello everyone. So, Vaishnavi will be coming up, summarizing the whole session. For a few of you thinking that was too fast, maybe that was actually. So, sure, we can get a recap again. Stay tuned.
Hey, hi guys. Am I audible? And is my screen visible? Our favorite two questions from the lockdown experience. Um, okay, I believe I'm audible and the screen is visible. So Ayush, that was a great session. But just to like summarize for the parts, like there were some network issues. I believe that is my fault because of this little Darth Vader over here I introduced. So I feel responsible to summarize the session a bit for the past parts we missed due to technical issues. So yeah, let's get right into it. And I was curious to ask, why did you choose the wine quality prediction? Ayush, we will talk about it later. So, as Megha, our ML team lead, covered yesterday, she covered data acquisition and data visualization. Still, we would run by it quickly. So now, just in case of some of you are not aware of this, so uh, you can do machine learning. With there are multiple programming languages you can use, right? But mainly, the two famous of them are R and Python. Now, in our ML study jams, we have unanimously chosen Python to work with. Okay, so now in Python, there are multiple libraries, out of which NumPy is to deal with linear algebra because kids, machine learning, the basics for machine learning is mathematics. But since this is a completely beginner track, we have came up with for you guys. So we have chosen not to delve into it right now. We just want to introduce you to the world of machine learning, and then if you feel interested in it, and then you can completely go ahead and explore it. We would be sharing loads of content with you post the whole MS study gems. So yeah, keep an eye out for that, will you? So yeah, so the NumPy libraries is to deal with the mathematical part. There are matrices and how, in what way there are matrices involved, we would see later in several minutes. Same is for pandas to process the data and to visualize the data, which we did yesterday, the friends data set, if you guys remember. So there are also multiple libraries for that, but mainly we are going with matplotlib and seaborn. Okay. So now this is a pretty famous data set, the wine quality prediction. So you can this function, the pd.readcsv, uh, what is PD? So you can use the whole. You don't have to write the whole pandas library's name. You can just give it a nickname, like this, like as import it as whatever you want to call it. So yeah, read CSV. Why CSV? Because our data set is in CSV format, right? We would. How does it look? Yes, let's run this. It's taking a little time. Until then, we can see the next steps. So now, okay, you import the data, but it's not. You don't always know how the data looks like. What if you miss on something? So then there are these multiple functions. So there are these multiple functions like .info, .head to see what's going on with our data. Is it all right or not? Okay. So yeah. So we can see that our wine quality prediction, we are predicting the quality based on different aspects like what is the alcohol content, what is the pH. If it's in Gujarat, it's probably zero. But yes, if it so this is what our features. This is what our whole prediction depends on, the factors. So yeah, then we can now let's see how what our data looks like. So this is this data in our CSV format. Okay. Now we would see why we have written the unique. So we are using df dot product to see the values in that column. Okay. So, but now there are two labels. I'm sure we have gone over this. So in machine learning, there are multiple types of machine learning: supervised, unsupervised, semi-supervised, transductive, reinforcement. Don't get overwhelmed, these are too many terms, but for now let's focus on. So this is a label data. At the end of the all the features, it is saying that okay, if this is the scenario, then the wine quality would be bad. If this is the scenario, then the wine quality would be good, right? So these are the labels. It is labeling a range of data. So we have chosen unique because now if there are thousands of columns, then it would like show the whole array of how many times that is bad and good. We don't want that. Like why unnecessarily? So we use the unique function to just see the unique labels and get done with it. What is the shape? So it is shape is the size of our data. We are not body shaming it. So there are 1600 you can say columns and mainly 12 features, right? So yeah, now we are encoding. So our data is in text format, the labels good or bad, but we all know that machines learn faster when it is in binary format, that is 0 and 1. So what we can do, the term we call that is encoding. We give them numbers instead of words. Like if there are 4 leads in this stream right now, then instead of making the machine learn all our names, you can just give us numbers 0, 1, 2, 3. So that's more easier to remember even for us. Just like that, we encode the labels for the machine or the model. Then we check if there are any empty features in the data, they are not. So this whole procedure is the part of data processing, data wrangling, data crunching, right? Again, after all this, we just make sure, just again to have a look at our data. Okay, now let's visualize our data. How many columns in a data set are labeled bad and how many of them are labeled good. So approximately 700 have bad and 800 and some more have good. So it is somewhat balanced, a data set, right? So this is to make sure that there is no bias. Now, what is bias? So it's like if you keep feeding a child, like you keep telling him, okay, this is good, this is good, this is good. He's going to remember this is good. But then what if he encounters something bad? Even then, if it's a little bit similar, he's going to think it's good. So for that to not happen, we make sure our data set is balanced and randomized so that it doesn't remember just one type of thing and then uh, otherwise it would affect the accuracy later a lot. Okay, now until that is running, we have this code over here to check the correlation. Now, what is the correlation? Now, not all the features that actually affect our final output, that is, would the wine would be good or bad. For example, if there is a row that says that the temperature that day, it might affect or might not. If the correlation of the temperature of that day doesn't affect, then the correlation would be very low. It would be towards zero, right? And and likewise, if the correlation is very high, then it would be towards one. So that is why we check the correlation to make sure that all the features we are fitting the model, there is no unnecessary data. So there is no redundancy, right? So to make sure all that, we go over the correlation matrix and everything. And guys, let me know if there are any questions in the chat right now. You can just feel free to interrupt in between. So we don't have to revisit the whole, right? Okay. Then histogram, right? So what does histogram tell us now? So the histogram tells us the distribution of our data, and if we think there is some bias or it is not, continuous. For a supervised learning model, the data should always be continuous. These are mathematical terms, and for an unsupervised model, the data should be discrete. Okay, like zero, like random numbers 0 1 that which have no correlation, but in supervised it is continuous, like for in 0 to 1, so that would be in decimals and it would be the whole curve would be continuous. So we check the histogram to see the distribution and make sure it's continuous. Otherwise we equalize the histogram. Then there are other terms like regularization and standardization to bring the whole data in a range to make it even more easier for the model to predict the correct outcome, and then we ignore the outliers which are not setting in a range. So this was the whole data crunching, data pre-processing procedure. Now models. Now when we talk about models, there are multiple models, all right, in machine learning. I don't have a PPT right now, but this was pretty much impromptu. But yes, so in supervised learning, we can say like the classic model we first learn is linear regression. Okay, so in supervised learning, there are two, regression and classification, these two terms. And in unsupervised learning, there is clustering and association. Okay, so regression and classification, for that, the first two classic models which anyone would be teaching you would be linear regression and logistic regression. And then for clustering and association, there is k-means clustering, right? Decision tree. So these are so many names. So don't, again, I'm saying this, don't get overwhelmed by all these terms and all. Get the core concept behind what we are. The core concept would be wrangling the data, playing with the data to get some information from it and to feed the model. That is the all what we are doing. Then when you get your head around the basic concepts, then delve deeper into how the models are working and what is the mathematical procedure behind that. All right. Now we would be dividing the data into training data and testing data. So in training data, like there is two columns. That one would be the features, and the one would be what we want, the whole, like the labels X and Y. So we are dropping the quality, that is our label, our target column, and we would be dividing them both. I think I have to run all again. So until that is happening, I would be continuing. So yeah, we are dropping the target column again. Then we would be dividing them into X and Y, features and target. Okay. Then we are splitting the training. Why training and testing data split is important. So we how are okay, we made the model, but how we are going to know, is the model working? Is it good? Is it bad? Is there is some work needed to be done on it? So that is why we test it. But so we take some part out of our data, and then we feed the X, the features column, to see whether it is predicting correctly or not. Then we compare the predictions with our the target column that we already had, and we compare them, and we see how correct it is or how wrong it is. So that is all about it. So here we have taken a 80% 80-20 split, 80% in training data, 20% for testing data. There is no ideal solution for it. Some would go 70-30, some would go 60-40. It depends on the how large the data set is at your hand. And the random state is, again, I was saying that we need a regularized, standardized data. So what the random state does is it keeps, we can say, shuffling the data, right? So that the model doesn't get overfitted or underfitted. Overfitted means it remembers a similar type of pattern, and underfitted means you can say it is not able to predict anything. Like it is just generating random predictions. All right. So that is why we scale the data here. Scaling, normalization, regularization. Okay, so they fall under the same roof. That is, okay. So we covered this. All right. So here Ayush chose to work with decision tree classifier. Okay. So let's see how this performs. So we declared the model, then we fitted our data. We fitted our data in that model. Then we see accuracy score of 1.0. That means 100% for training set, and 71.25% for testing set. But again, there are also other ways to evaluate a model, just not the accuracy score. So here is one more matrix, that is confusion matrix. Now I wish I could draw this. So what it does is it compares your accuracy in terms of true positives, false positives, and false negatives, true negatives. Now how that works is, if you're for example 0 and 1, consider 1 as positive and 0 as negative. So if you're supposed to predict it as 1, that is true positive, and the model also predicts that it is a 1, this is true positive. But if it predicts at 0, then it would be false negative. So I would make sure to include this all in the documentation we would be sharing later. I am aware that remembering all this just orally would be a bit difficult and confusing, but also it's a YouTube stream, so you can just pause it right now and search it also. Okay. So yeah, this is how like a confusion matrix works. It evaluates on basis of true positives, true negatives, false positives, false negatives. And then there are other terms known as precision, recall, and F1 score. So I don't think we should be getting into it very much right now. This is an introductory course, but you should be aware, okay, what kind of metrics would be there if I want to evaluate a model. So it's confusion matrix. Then you can just look it up and then get it into much more detail later. All right. So as I said, the confusion matrix is based on precision, recall, F1 score, right? So we can see here, the precision is based okay, if you want to like just have an idea कि okay मैंने कहीं पे ये सुना हुआ है, so precision is based on like true positives compared to like number of uh, true positives against number of positives plus false positives, and similarly recall is based on true negatives against true negatives plus false negatives. And F1 score is a weighted average of precision recall. What is a weighted average? So this is again a mathematical term. So like you can imagine it like the multiplication of two elements divided by their addition. You can that is we generally mathematically called as weighted average. So all right, we crunched the data, we visualized the data, we created the model. We also worked upon the overfitting and underfitting a bit. So good going, guys. Right. So again, we have some more models. But yeah, so that was I was just trying to summarize this a bit. But if we have any more questions, yeah. Okay, Hariom, you can take over. Sure. Make sure you join our next session, which will be in just 5 minutes at 4 p.m. Preet would be taking it. It is Introduction to Deep Learning. So let's see. See you then.
All right, so thank you so much for delivering such a delightful session. Ayush and Vaishnavi, thank you to both of you. And I hope the session was really helpful to all our attendees and they have find this more informative and educative. Yes, as mentioned, we are meeting soon within a 20 minutes of break for our session 3 under machine learning study jams. So I would request you not to miss that session because that session now would be taken from Preet Thakkar and he would be educating you neural networking and deep learning. So get yourself freshen up and hydrated. We'll be meeting soon. Thank you so much.